Hey guys, here's your Chapter 7 review. Just a couple of problems. I'll do a couple of the graphs. So here's one of the graphs. I know it's kind of blurry, but I can't get a better photo of it. So we have to write this equation in factored form. So remember, factored form is with your parentheses. So we would have y equals a times x minus x minus root 2, and we would however many roots we have. So we start finding roots by looking at our x-axis. So here's one at -2, here's another at 0, and another at 2. Now the important thing is this one at 0, since the graph does not go through the x-axis, this is a double root. So I'll actually have 2 zeros when I write the equation, so I'll have 4 roots. So we write y equals a times x minus -2, so x plus 2, x minus 0. I can either write that again or I can just square it, which I'm going to square it, and then x minus +2, so x minus 2. So that's the start of factored form. I need to find a. So on the test, you'll be given the point they want you to use for a. Here, I wrote it in. It's the point 1, -3, and you can see that right here. So we're going to plug in 1 for x and -3 for y, and then figure out what a is. Okay, and I'm just going to do that on the next screen so that I have more room and you can see what's going on. So I have the equation y equals a times x plus 2, x minus 0 squared, and x minus 2, and I'm using the point 1, -3 for my x and my y so that I can find a. So I'll plug in -3 equals a times, and then I plug in 1. So 1 plus 2, 1 minus 0 squared, and 1 minus 2. So -3 equals a times 3 times 1 squared and times -1. -3 equals a. 1 squared is 1. 1 times 3 is 3. And 3 times -1 is -3. So I have to divide both sides by -3 to find out that a equals 1. So my final answer is I take that value for a and I rewrite my equation with a in it. So y equals 1 times x plus 2, x minus 0 squared, and x minus 2. And there is the solution for problem 1, number 2. Okay? Alright, so problem 1, number 1, I think I have that one also. So here's the graph for that. Again, same idea, we look for our roots, so there's a root here at -2 and a root here at 1. This is a double, so I'll have 2 for 1, so I have y equals a times x plus 2 and x minus 1, and this will be squared because there's 2. It's a double root. Again, I wrote in the point. I'm going to use a y-intercept this time, 0, 2. So I can plug in 0 for x and 2 for y. Now plugging in a 0 for x just gives me exactly the numbers that are there. So I would get 2 equals a times 2 times -1 squared. -1 squared is +1. So I get 2 times +1, which is 2. So this is 2 equals a times 2, and I divide both sides by 2, so again a is equal to 1. So my equation for this graph is y equals 1 times x plus 2 times x minus 1 squared. Alright, so you need important to remember your double roots and how to solve for a. In problem 2, we have rational root theorem. So we have to go through and complete all those things, A, B, C, and D, for our rational roots. I'm going to do another problem too for the rational root theorem. So this theorem, or this problem rather, I had you change on the board. P of x equals 2x to the fourth plus 6x to the third minus 4x squared minus 20x minus 24. So for A, or in your packet it says E, but either way. So for E, possible rational zeros of the function. So this is your rational root theorem. And this is where you need your P's and your Q's. So P and Q. P is your constant, remember, so negative 24. Q is your leading coefficient, so 2. And then we do factors. So factors of 24 plus minus 1 plus minus 2 plus minus 3 plus minus 4 plus minus 6 plus minus 8 plus minus 12 and plus minus 24. For Q, we just have plus minus 1 and plus minus 2. So now we divide to find our possibles. We divide P over Q, and that's how we get our possible rational roots. So I'm going to take 1 and divide it by 1, so that gives me 1. Then I take 2 and divide it by 1, so that gives me 2. 3 divided by 1 is 3. 4 divided by 1 is 4, 6 divided by 1 is 6, 8 divided by 1 is 8, 12 divided by 1 is 12, and 24 divided by 1 is 24. Then I go through my P's again, but this time I use the 2. So 1 divided by 2, that's 1/2. 2 divided by 2 is 1. I have that already, so I don't have to rewrite it. 3 divided by 2 is 3 over 2. Notice we leave the fractions, we don't go to the decimals. 4 divided by 2 is 2, that's already there. 6 divided by 2 is 3, that's already there. 8 divided by 2 is 4, that's already there. 12 divided by 2 is 6, already there. And 24 divided by 2 is 12, which is already there, so I don't have to list them again. So for letter E, or A on the test, or whatever, this is what I'm going to be looking for, the list of all your possible rational roots. From there, we have to find all the rational zeros. Now, I don't have the calculator app that I have at school, so you're just going to have to trust me when you put this in the calculator. Remember, we look for our zeros by using the trace feature on our calculator. And when we do that, for letter F or B, whatever you want to call it, from the graph, it looks like x equals -3 and x equals 2. Now remember, we go back and we look in our list of possibilities to see if they were part of our possibilities. Well, here's the 2 and here's the -3. So definitely part of our possibilities. Also remember, if from the graph I get a decimal answer, I'm going to check to see if it matches the fraction. If it matches the fraction, you use the fraction to do your synthetic division. You do not use the decimal, because more times than not, the decimal is rounded and you're not going to get nice answers. So you always use the fraction. But in this case, we have whole numbers, so I don't have to worry about that. So for part F, I want to make sure that these are right. I have them on the graph, I've checked them, they're in my possibilities, but to actually prove it, we use our synthetic division. So I'll do the -3 first. I have to get my coefficients. Remember, your coefficients come from the original problem. So 2, 6, -4, -20, and -24. 2, 6, -4, -20, and -24. Okay. And we do our synthetic. Ready? Drop it down, multiply, add, 0, multiply 0, add, -4, multiply, +12, add, -8, multiply, +24, add 0. Awesome! So that means that one of our rational roots, just going to make a little rational roots, I get x equals -3. So now I know for sure that that works because I got that 0 remainder. So now I do this again because I have a second root, the 2, and I use these numbers. So I have 2, 0, -4, and -8. And if you've already done this problem and you use 2 first, relax, it's fine. You will get the same solution. Just hang in there for a minute. So I drop this down. 2 times 2 is 4. Add 4. Multiply 8. Add 4. Multiply 8. Add 0. Excellent. So our other root is definitely x equals 2. And here's my answer for part F, or part B. Okay? Finding the other zeros is where we take the solution from here, which is now a quadratic formula, and we use the quadratic formula to find our either imaginary or irrational roots. So that's part G. So part G, we're taking that equation, so 2x squared plus 4x plus 4, and we're going to use the quadratic formula. So here's A, B, C. So I have the opposite of B plus or minus the square root of B squared minus 4 times A times C divided by 2 times A. Going through to solve, we end up with -4 plus or minus the square root of 16 minus 8 times 4, 32 over 4. So this is -4 plus or minus the square root of -16 over 4. Remember, square root of -16. So we've been practicing simplifying square roots. And negative always comes out as an I, because it's an imaginary number, because you can't really have a negative square root. And the square root of 16 is a perfect square. The square root of 16 is 4, so that's 4i. I still have the plus or minus, and in front of that plus or minus, I still have this -4. And everything is still divided by a positive 4. When we do the division here, we divide the real parts and the imaginary parts. And we get here -1 plus or minus 1i, or just I. And this is our solution for part G, our other zeros. Actually, let me just erase so that I can actually put it in an answer. So the other zeros, and I promise I gave you more room. Actually, it's pretty much set up like this, so you should have enough room. So the other zeros are x equals -1 plus I, and x equals -1 minus I. That kind of looks like a U. Okay? So there's my answer for G, the other zeros. So for H, we just need to write all of our zeros together in factored form. So for H, factored form, let me just write down all of my zeros, the rational and the others. So I found that x was -3, x was 2, x was -1 plus I, and x is -1 minus I. So I have 4 zeros, which means I'm going to have 4 roots. X minus the first root, x minus the second root, x minus the third root, and x minus the fourth root. So let's go ahead and fill these in. So y equals, I'm going to leave a alone for now, x, and remember, since all of these are subtraction, that's why our numbers always go in as opposites. So -3 is +3, +2, -2, -1 plus 1 plus I minus I, -1 plus 1 minus I plus I. Okay, we change the sign of everything. Now remember our shortcut for A. I don't want to have to go and plug in a y-intercept or do any of that. Since I already had the equation in general form all the way back at the beginning, the number in the very front, the leading coefficient, is my a value. So my a value is 2. And all I have to do is go back, look at the problem, and remember to put it in. And that is the real answer that you're going for, that all of these steps, E, F, and G, help you get to. Okay, so that's your factored form. All right, one more. Problem number 3, I'm going to do the first one, number 1. The first one's harder than the second one, so I figure you might as well do a harder example, and then you can do the easier one to solve that. Okay. So problem number 3, number 1. Write an equation in general form for a 4th degree polynomial with real coefficients, zeros 2i and negative 1 minus 3i, and a y-intercept of negative 10. So zeros are 2i and negative 1 minus 3i. Y-intercept is negative 10. So what they're not telling you here is that you also have a 0 at negative 2i, because it's imaginary, so you have the conjugate. And you also have a 0 at negative 1 plus 3i, because again, it's imaginary, so you have the conjugate. And the y-intercept is negative 10, which means you have an x value of 0 and a y value of negative 10. So what we have to do here is we have to start with factored form, and then we'll go to general form after we find our value for a. So factored form, we're going to plug in all of our zeros. I'm going to start it here and then I'll rewrite it on the other page. But so y equals, I don't know a, plug in the zeros. So the positive 2i changes, it's opposite. The negative 2i changes, it's opposite. The minus 1 changes, the minus 3 changes, the minus 1 changes, and the positive 3i changes. Okay, so there's the factored form. I'm going to take that x and y from the y-intercept here and plug that in. So I'll have a negative 10 in for y equals, and then x's will all turn to 0. So these will all be zeros. So I'll have a times negative 2i, positive 2i, 1 plus 3i, and 1 minus 3i. So now that I'm here, I have to multiply all those out in order to find a. So that's what I'm going to go to the next slide for. So I'm just going to rewrite that. Next year I really have to learn how to copy and paste so that I don't have to do this over every time. Oops. Okay, so here we have everything. And remember, when we multiply, we take them 2 at a time. So I'm going to do those 2 and these 2. I try to keep it with its conjugate so that the i's will cancel for us, which is what we need to happen. So, oh, that wasn't a y. What was that? Negative 10. Sorry. So there's the negative 10. So I have negative 10 equals a. And then these I can just multiply. Negative 2 and negative 2 is negative 4. I times I is I squared. And here I'm just going to FOIL these. So I have 1 times 1 is 1. 1 times 3i is 3i. Negative 3i times 1 is negative 3i. And negative 3 times negative 3i is negative 9i squared. Okay, going through. I squared turns to a negative 1. So this is negative 4 times negative 1. That makes a positive 4. Here, the 3i and the negative 3i cancel. I have negative 9 times I squared, which is times negative 1. So that's a positive 9. So I have 1 plus 9, which is a positive 10. I have a out front, and it equals negative 10. Continuing to simplify, we multiply. Negative 10 equals a times 4 times 10 is 40. And now finally I can solve for a by dividing both sides by the number next to it, which is 40. Negative 10 divided by 40 is a negative 1/4 or negative 0.25. So a equals negative 0.25. So I'm going to go back and take this blue equation that I had here and put my x's back in and change my a to negative 0.25, and I'll have factored form of the equation that I then need to get into general form. So let's go back to that. So I'll have y equals negative 0.25 times x minus 2i times x plus 2i times x plus 1 minus 3i times x plus 1 plus 3i. Okay, so that's a start. Seems like it should be the finish, but that's the start because the question does ask for general form, and right now all I have is factored form. So general form is when we have to take what we have and go back in and multiply and FOIL everything out. This is where we use our area models because it gets a little bit messy. So I'm going to save this screen for the next one that I'm going to write. So I'm just going to bring down what I'm not going to use right now, negative 0.25. And then I'm going to multiply x minus 2i and x plus 2i. I really could FOIL this. I'm just going to stick with area model just to go through it. So x minus 2i and x plus 2i. Remember, my imaginary numbers should cancel. So this becomes x squared minus 2ix, and negative 4i squared. So my 2ix and my negative 2ix, these guys cancel. The negative 4i squared, remember I squared is a negative 1, so this is negative 4 times negative 1, which gives me a positive 4. So I have x squared plus 4. So that's what that first bracket simplifies into, x squared plus 4. Now I have to do the second bracket, which is a little bit more complicated because it's a 3 by 3. So that one, I just might as well erase this. Again, you know me by now, I work fast, so pause as needed. So this was an x, a positive 1, and a positive 3i, an x, a positive 1, and a negative 3i. And so we get x squared, 1x, 3ix, 1x, 1, 3i, negative 3ix, negative 3i, and negative 9i squared. So again, going back through, my i's should cancel. Through negative 3ix with positive 3ix, negative 3i with positive 3i, and again with the I squared, that's a negative 1. So negative 9 times negative 1 is a positive 9. Here I'm going to have to combine some like terms because I do have a couple more terms than I did in the last one. So my x squared, there's still nothing to put that with, but I have a 1x and a 1x, which makes 2x, and I have a 1 and a positive 9, which makes 10. So this is what's going to go in my second set of parentheses. X squared plus 2x plus 10. X squared plus 2x plus 10. Okay. Last step to FOIL. We have these two parentheses that are now left. So I'm going to have x squared plus 4 and x squared plus 2x plus 10. So this time I have a 2 by 3, a little bit less than this last one we've done, but a little bit more than the first. So I have a 2 by 3, and I definitely left more room on this one for you to do. I don't know why my boxes are so uneven there, but that's what we got. So I have x squared, 2x, and 10 here, and then the x squared and the 4 here. Fill them in using your rules of exponents. This is x to the 4th, this is 2x squared, This is 10x squared. Oh, this isn't 2x squared. Hope you caught that. 2x to the third. 10x squared. This is 4x squared. 8x and 40. So again, we'll go through combining like terms. X to the fourth, there's nothing like that, so it's just x to the fourth. 2x to the third, nothing like that, so just 2x to the third. 10x squared and 4x squared, got the 14x squared. The 8x is alone and the 40 is alone. So here is my last FOIL. So let's go plug that in. So y equals negative 0.25 times x to the fourth plus 2x to the third plus 14x squared plus 8x plus 40. And then, as if that wasn't enough, the very last step, we have to distribute our vertical scale factor, the negative 0.25. So finally, we have negative 0.25 x to the fourth minus 0.5 x to the third minus 3.5 x squared minus 2x minus 10. And that is our solution to problem 3, number 1. Lots of work. Just take it slow, draw your area models, and take your time doing your multiplication, because where you're going to make a mistake is with your positives and your negatives and maybe with your i's. Okay? All right, so if you just want to hang on, I will just go through and give you the answers to the other pieces. That way you can check when you do the other problems for homework. You can check to see if you're right. So if you go back to the first page, problem 1, whoops, can't write in squares, you're not going to understand that. So problem 1, number 3, you should have y equals 1 times x plus 3 times x plus 1 times x minus 1. For number 4, you should have y equals 1 times x minus 0 squared, that's a double root, and x minus 2. So that's for problem 1. I think with most of you in class, I've already done problem 2, the rational root theorem. But again, I'll just give you those. So for A, so this is, whoops, problem 2. So for A, you should have plus or minus 1, plus or minus 3, plus or minus 13, plus or minus 39, plus or minus 1/3, and plus or minus 13/3. For B, you should have found x equals negative 1/3 and x equals 3. For C, you should have found x equals 2 plus 3i and x equals 2 minus 3i. And for D, your equation should be y equals 3 times x plus 1/3, x minus 3, x minus 2 minus 3i, and x minus 2 plus 3i. So that's problem 2. I did the other one with you. And problem 3, number 2, your factored form should be 2.5 times x plus 4i, x minus 4i, x plus I, and x minus I. But the general form, the answer that you actually need to have in order to get any credit, would be y equals 2.5 x to the fourth plus 42.5 x squared plus 40. This is the actual answer. You had to go through that factored form to get to that, but that's the one that you need. All right. Any other questions, bring them to the table, but we're going to pretty much take the full time to get the test done next time I see you in class. Make sure you study up.